Salam and welcome everyone. So today we're going to be working on the question on the screen that says, to what speed must a proton be accelerated for it to have a de Broglie wavelength of 3.0 centimeter? Now, I want to quickly mention that this question is from the Atkins Physical Chemistry 11th edition textbook, and I have done a very similar question to this on my channel, although the other question involved an electron, not a proton. And this question involves a proton. So I would just want to say this is from chapter 7A of the textbook, where we're going to be dealing with quantum theory and quantum mechanics. So yeah, that's the main thing. So, to what speed must a proton be accelerated for it to have a de Broglie wavelength of 3.0 centimeter? So, what we are asked to solve for is the speed. We're given the wavelength to be 3.0 centimeter. So, we can easily convert from centimeter to milliliter. So, it's going to be 3.0 times 10 raised to the power of negative 2 meters. And we're told to calculate the de Broglie wavelength. Now, to solve a question like this, you have to use the de Broglie relation formula, which simply says lambda wavelength is equal to h divided by p, where p is equal to linear momentum and h is equals to Planck's constant, and then lambda is equal to wavelength. Yeah, that's basically it. And the question is literally asking us to determine velocity. So, how do we go from velocity when all we're given is the Planck's constant as well as the wavelength? Well, we have to remember that P, being linear momentum, is just basically what we've been taught in um, high school. If you did science in high school, you learned this in physics or even in early elementary physics in college. P, linear momentum, is just simply mass times velocity. So momentum, linear momentum, is simply mass times velocity. So all we can simply do right here is for us to substitute. So lambda is equal to h divided by, we're going to substitute mv for p here. So h divided by mv. So we cross multiply and we end up getting lambda m times v is equal to h, where v is equal to h divided by lambda m. So that is it. V is equal to what? V is equal to h divided by what? Lambda m. So V is equal to 6.626 times 10 raised to the power of negative 34 joule seconds, because the value for Planck's constant is a constant. Remember, Planck's constant, it's a constant with value of 6.626 times 10 raised to the power of negative 34 joule seconds. And I want to advise you guys to please look at all the videos on my channel that involve quantum theory or physical chemistry, because the more you watch the videos and the more you learn, you're going to be able to know how all of these formulas and all of these concepts are how they all come together in your knowledge of physical chemistry. So anyways, that is that divided by the wavelength. We know the wavelength to be 3.0 times 10 raised to the power of negative 2 meters. So 3.0 times 10 raised to the power of negative 2 meters times the mass. So as you can see, they did not give us the mass of proton in the question. But if you've done, of course, you guys would have done it, but general chemistry and introduction to chemistry or high school chemistry, you would learn the mass of proton. The mass of proton is the value 1.67. You can always Google it as well, or you can check the back of that Kids Physical Chemistry 11th edition textbook. It's there. 1.6762 times 10 raised to the power of negative 27 kilogram. So this is basically it. Now you're gonna be wondering, what is going on here? We normally, anytime we're doing calculations, we want to make sure that we can easily cancel stuff out. We'll see here now that we have joules, we have seconds, we have mass, we have meters, and we have kilogram. And you're gonna be wondering, how do I even work with this information? Well, to get the SI units, we have to remember that joules is not in SI units. Joules is actually equal to kilogram meter square per second square, where joules is the unit of energy. And energy, for example, is what? Force times distance, okay? And force is just simply mass times acceleration times distance. So energy is mass times acceleration times distance, right? So the unit for mass, the SI unit for mass, we know that to be kilogram. The SI unit for acceleration, we know that to be meter per second square. And unit for distance, SI unit is just meters. So that's why you end up with kilogram meter square per second square. So that's why the unit of joules is kilogram meter square per second square. And don't forget, Planck's constant is joule seconds. So let me just rewrite it here. We end up with 6.626 times 10 raised to the power of negative 34. Okay. Joules is again kilogram meter square per second square. But don't forget, we're not just dealing with joules, we're dealing with joules seconds, right? Joules seconds. So just say times second. Okay. All of this divided by 3.0 times 10 raised to the power of negative 2 meters times 1.67262 times 10 raised to the power of negative 27 kilograms. So that is basically it right here. So you cancel out kilogram, cancel out from meter square, cancel out meters, cancel out seconds here, cancel out this one. So the velocity ends up just becoming 6.626 times 10 to the power of negative 34 divided by 3.0 divided by 3.0 times 10 to the power of negative 2 times 1.67262 times 10 to the power of negative 27. So when you do all of that, you end up getting 1.32048 times 10 raised to the power of negative 5 meter per second. And also, do not forget, we are chemists, so we have to put our work in the proper number of significant figures. And if you look at the initial part of the question, we have two sig figs latest. So the proper number of significant figures is just simply velocity is 1.3 times 10 raised to the power of negative 5 meter per second. So that is basically the answer to this question. So yeah, if you have any questions, suggestions, concerns, observations, please put in the comment section. I am fully involved in this channel, and I'm trying to make sure that it's actually grows and actually start tutor students what they actually like with the style of tutoring that is the most impactful in your learning journey. So I also wanted to mention that if you're a student who is struggling with any of your STEM related courses, whether you're in middle school, high school, or college, I am the tutor for you. I help students in academia to succeed in a wide variety of STEM courses where I tutor and mentor them in order for them to have the best academic life. So if you would like me to add value to your life in that way by using my services, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.